Hello friends, welcome to my new data structures and algorithm in Java tutorial series video. Friends, in this tutorial we will discuss binary search in Java. So friends, what is a binary search? Binary search is a divide and conquer algorithm. So here if you see that suppose if we are given an array which is sorted. So here you can see the numbers are sorted in ascending order. So friends, let's suppose we want to search an element in a sorted array. So what we can do is either we can perform a linear search, that we can compare the elements with an array with an element we want to search. So this linear search will go on with the each and every element that we first check with the number at 0th index, then 1, then 2, then 3, and it goes on till the end of the array. But here if the array is sorted, then instead of doing a linear search we can do a binary search. So what we can do is we can repeatedly divide an array into half, and with each division we know that we are dividing the array into two halves. So we usually compare the element we want to search with the middle element, and if suppose the element we want to search is less than the middle element, then we can ignore the other half and we can search in the first half. And if the element we want to search is greater than the middle element, then we can ignore the first half and we can search in the last half. So below you can see the algorithm for the binary search. Now let's see the demonstration of this algorithm step by step. So suppose we are given an array having 9 elements, and here you can see the array is sorted. So suppose we want to search a key having the value of 65. Now we know that 65 is in the array and we want to search it using the binary search. So what we can do is, so the first step what we do is we create an integer variable by name low and we assign a value of 0 to it. So here you can see low is having value of 0. So here it means that we are pointing at the first element of an array at the index 0. Moving ahead, and then we create an integer variable by name high and we assign it a value of say numbers.length -1. So here what we are actually doing, in the first step we created an integer variable low and we are pointing it to the first index, and then we are creating an integer variable high which will point to the last index of an array, which is 8. So here if you see there are total 9 elements in an array, and when we do numbers.length we get 9, and when we do -1 we get the 8. So it just means that high is having value as 8 and it is pointing to the last element of an array. So friend, as the array is sorted and we are applying binary search over it, so we are using this while loop, and inside this while loop in each iteration we will divide the array into two halves and we will search for the key 65. So the condition we are placing in the while loop is we will iterate till low is less than equal to high. So currently you can see low is pointing to the 0th index and high is pointing to the 8th index. Therefore low is less than high. So the condition in while block comes out to be true. So in the first step what we are actually doing is we are actually finding the middle element of the array. So in order to find the middle element, the formula we are using here is we are doing high plus low and we are dividing it by 2. So currently high is having a value as 8 and low is having a value of 0. So when we will do 8 plus 0 by 2, we get mid as 4. So here mid will point to the index 4, which is nothing but the middle element of this array. Moving ahead. So friends, here you can see as mid is pointing to the middle element of an array, we know that array is divided into two parts, from low to middle and from middle to high. So first we'll check whether the value at mid position is equal to key or not. So if the element is equal to key, then we have found our key and we'll simply return the value of index. So currently you can see the value at mid is 59, and if we compare it with the key, then 59 is not equal to 65. Therefore the condition in if block comes out to be false. and then we will check that whether key 65 is less than 59 or not. So here you can see 65 is not less than 59. Therefore the condition in if block comes out to be false, and the else block will be executed. So friends, here you can see as array is sorted, and we have identified that key 65 is greater than the middle value. Therefore we know that 65 would be somewhere in the last half. So now we can ignore the first half and we can directly search into the last half. So this is how this algorithm works. We actually divide using this middle element, and we compare it with the middle value, and if the value is greater than the middle value, we search in the last half, and if it is less than the middle value, then we search in the first half. So now the overhead of searching in first half is gone, and we can directly perform our search in the last half. So what here actually we do is, currently low was pointing to the 0th index, and now we know that our key will be lying between the index 4 and 8. So therefore to the low we are assigning the value as mid plus 1. So it would look something like this, that now low will be having value as 5, and it will point to the 5th index. Moving ahead, now in while loop we will check whether low is less than equal to high or not. So currently low is having value as 5 and high is having value as 8. Therefore 5 is less than 8. So the condition in while block comes out to be true. So now in the first step we'll again find the middle index. So we apply the formula as high plus low divided by 2. So currently you can see high is 8 and low is 5. So when we do 8 plus 5, we get 13, and when we divide it by 2 we get 6.5, and when we take it as integer variable the value is rounded off to 6. So now mid will hold the value as 6. So friends, here you can see we have again divided the array into two halves using this middle index. So in the first step we will check whether the value at mid is equal to key or not. So currently here you can see that value at mid, which is 75, is not equal to our key, which is 65. Therefore the condition in if block comes out to be false. And then we check whether our key is less than this middle value or not. So if key is less than this middle value, then we know that we have to search into the first half. And if key is greater than the middle value, then we know that we have to search in the last half. So currently key, which is 65, is less than 75. Therefore the condition in if block comes out to be true. So friends, here we know that as key 65 is less than 75, so therefore it must be lying somewhere between the low index and the middle index, which is nothing but the first half. So now our high will become mid minus 1 because we have to search in the first half. So therefore here you can see mid is 6. So when we do mid minus 1, high will store the value as 5. So friends, here the key 65 was less than the mid value. Therefore we knew that it must be lying somewhere between the low index and the middle index. So therefore we assign the value of mid minus 1 to high, so that now we can search in the first half of an array. Moving ahead, we will again check whether low is less than equal to high or not. So currently low is having value as 5 and high is also having value as 5. So therefore the condition in while block comes out to be true. And we'll again find the middle index by the formula high plus low, and then we'll divide it by 2. So here you can see high is having value 5 and low is also having value as 5. So when we do high plus low we get value as 10, and when we divide it by 2 we get value as 5. So now value of 5 will be assigned to the mid here, and now mid will point to the 5th index. So friends, in the if block we will check that whether the middle value is equal to key or not. So here you can see the middle value, which is 65, is equal to the key 65. Therefore the condition in if block comes out to be true. So it means that we have found our key. So we can simply return the index position, which is nothing but the fifth index. And if we don't find any value in an array till low is less than or equal to high, then we can come to know that element is not in the array, and then we can simply return the index as -1. So friends, let's go to Eclipse and see the working code. So friends, here I have created one class by name binary search. So inside this class I will be creating the method which can actually perform the binary search. So let's create a method as public int. So this method will return us back an integer value, and I will name it as binary search. And this method will take two things. One is the integer array, which is actually sorted array. Another would be the key, which we want to search in the sorted array. So in the first step, what we do is we create an integer variable by name low, and we'll assign a value of 0 to it, which is nothing but the 0th index of an array. And we'll also create an integer variable by name high, and we'll assign it a value of last index of an array. So we'll simply do nums.length -1. So now high will be pointing to the last index of an array, and then we'll provide a while loop, and in the while loop we'll provide a condition as low should be less than equal to high. So we'll iterate in the while loop till low is less than equal to high. So in the first step, what we do is we actually divide the array and we find the middle index. So we'll create an integer variable by name mid, and we will assign it a mid value by applying the formula as high plus low divided by 2. So this formula will return us back the middle index of an array. After finding the middle index, we will simply check that value stored at the middle index is equal to our key or not. So if the mid value is equal to key, then we know that we have found our key, and we can simply return the mid index. And if suppose the value at middle index is not equal to our key, then we can provide an if else block. So in the if block we will provide the condition as that if key is not equal to the middle value, then it must be less than mid value or greater than mid value. So if key is less than the mid value, then we know that key lies in the first half of an array. So we'll simply assign the value mid -1 to high, and in the else block we'll simply assign mid plus 1 value to low, because we know that if key is greater than the middle value, then we can ignore the first half and we can start searching in the last half. So at that time low will become mid plus 1. So in the while loop, if we find our key, then we can simply return the mid index, and if we didn't find our key, then we can simply return -1, which is nothing but the negative index. So friend, this is the code for binary search. Now let's test its working in the main method. So here first we have initialized the binary search class, and then I have created one sorted array which we discussed in the slide. So friends, let's search for a key having value as 65. So here I will be providing system.out.println statement, and here we will print the index. So we'll use this binary search instance and we'll call binary search method, and inside this method we'll pass the sorted array, and let's say we want to search for the key as 65. So friends, here we know that 65 is in the sorted array. So if I run the code now, you can see it returned 5, which means that we have found our key at the 5th index. So here you can see 0, 1, 2, 3, 4 and 5th index. So it is actually returning the 5th index where we have actually found our key. And let's say if I provide the value as say 100, and we know that 100 is not in this sorted array. So if I run the code now, so here you can see it returned -1, which is the negative index because it didn't find 100 in this sorted array. So it finally returned -1. So friends, in this tutorial we discussed about the binary search in Java. I hope you like this video. Please like, comment, share and subscribe my YouTube channel. Thanks, have a nice day.